So here we need to determine the limiting value of the given trigonometric function when x approaches pi over 2. Now we have cos 3x in the numerator. Now cos 3x can be expanded as cosine of 3x. The expanded value of cosine of 3x is equals to 4 cos cubed x minus 3 cos x. So let us substitute this value into our function. So we'll have limit x approaching pi over 2. So we have 4 cos cubed x minus 3 cosine of x plus 3 cosine of x divided by pi over 2 minus x whole cube. Now the negative 3 cos x plus 3 cos x gets cancelled. Now we have 4 cos cube x in the numerator. So now what we're going to do, we're going to change the limit. So we have limit h approaching 0, 4 times cosine of pi over 2 plus h whole cube divided by pi over 2 minus of pi over 2 plus h whole cube. Now we know that cosine of 90 plus theta, where theta is h, is equals to sine h. But we being in the second quadrant, so in the second quadrant our sine function is positive, but we are working with the cosine function, so we'll get negative sine of h. So we have limit h approaching 0, 4 times negative sine of h whole cube divided by, so the pi over 2 and negative pi over 2 will get cancelled. So we have negative h whole cube in the denominator. This will be equals to limit, so 4 can be taken out, h approaching 0, negative sine h whole cube. All we can do is we can rewrite it as, so this what we can do, the negative and negative from both the numerator and the denominator will cancel out and it will become positive whole cube, so which will be equals to 4 times limit h approaching 0 sine h over h whole cube. And we know that the limiting value of sine h over h when h approaches 0 is going to be 1, so we have 1 cubed. So that will give us a limiting value of 4. So let us move on to the next question. So here we have sine x minus sine of a divided by x minus a. We need to find its limiting value when x approaches a. So what we're going to do is we're going to change the limit from x to h. So we have limit h approaching 0, sine of this will become h plus a minus sine a divided by h plus a minus a, which will be equals to limit h approaching 0. So sine h plus a is an identity, we can expand it, and this will become sine a times cosine of h plus cosine of a times sine of h minus sine of a divided by h. So the a and a gets cancelled. Now what we're going to do, we're going to take sine a common from the first term and the third term. So we'll get limit h tends to 0. So we have sine a common factor. So we have cosine of h minus 1 plus cosine of a times sine of h divided by h. Now we are going to take negative 1 as the common factor, we'll have negative sine of a, and cos h minus 1 will become 1 minus cosine of h, plus cosine of a times sine of h divided by h. So this was done because we can change 1 minus cosine of h to a sine function. So that will give us limit h tending to 0, negative sine a times 2 sine squared h over 2 plus cosine of a times sine h divided by h. Now we separate the two terms, so we have negative sine a as a constant. So we have negative sine a times limit h tending to 0. So we can also take out 2. So we'll be left with sine squared h over 2 divided by h plus cosine of a times limit h tends to 0. So we have sine h over h. So now what we can do in the first term, so we have h in the denominator, so we multiply by h and multiply the entire function by h. We also divide h squared by 4, which will mean we'll have to divide h by 4. So now rewriting everything, we have negative 2 sine a times limit h approaching 0 sine h over 2 divided by h over 2 whole squared times limit h approaching 0 h over 4 plus cosine of a times limit h approaching 0 sine of h over h. Now we use the definition, so we have sine of h over h, the limiting value when h approaches 0 is going to be equals to 1. So we have negative 2 sine a times 1. Now the limiting value of h over 4 is going to be 0 over 4, so this is going to be 0 plus cosine of a times 1. So the first term will become 0, so we are left with cosine of a. So this is going to be the limiting value of our function when this is the function sin x minus sine of a divided by cos minus a. So we got the limiting value of cosine of a when x approaches a. Let us do another problem. So here we have the function sine 3x minus 3 sine x divided by pi minus x whole cube. So we have to determine its limiting value when x approaches pi. Clearly, when you substitute for the value of pi, we have an indeterminate form of 0 over 0. So that means we will need to simplify our given function. Now what we're going to do here, we're going to use the identity that sine 3x is equals to 3 sine x minus 4 sine cubed x. So let us substitute this value into a function. So we have limit x approaching pi. We have 3 sine x minus 4 sine cubed x minus 3 sine x divided by pi minus x whole cubed. So we can cancel out 3 sine x and negative 3 sine x, and this will be equals to limit x approaching pi. So we have negative 4 sine cubed x divided by pi minus x whole cubed. Now we're going to change the limit from x to h. So we have limit h approaching 0. So we have negative 4 sine cubed h plus pi divided by pi minus pi plus h whole cubed. Now we can take the negative 4 to the front of the limit. So we have limit h approaching 0. Now sine pi plus h is going to be equals to sine of h. Also, pi of pi plus h, that means this is in the third quadrant, and in the third quadrant we have only the tangent function which is positive, so the sine function will be negative. So we have negative sine of h, and when we cube it, that means we'll have negative sine of h whole cube. So this is simply going to give us negative sine cubed h. So we have negative sine cubed h divided by, so pi and pi gets cancelled, so we'll have a negative h cubed. So the negative sign will get cancelled, we'll be left with 4 times the limit h tends to 0 sine h over h whole cubed, and our limiting value of sine h over h when h approaches 0 is 1. So we have negative 4 times 1. So our limiting value is going to be negative 4 for the given function when x approaches pi. Let us do another problem. So let us begin by changing the limiting value from x to h. So we have limit h approaching 0 cosine of, so x will get replaced by pi by 2 plus h divided by pi by 2 minus pi by 2 plus h. So we have cosine of 90 plus theta, so that becomes sine theta. Let me write it down. So we have cosine of pi by 2 plus h. So this will be equals to sine of h, but this is in the second quadrant, our angle pi over 2 plus h. And in the second quadrant we have the sine function which is positive. Since we are working with a cosine function, so this translates to a negative value. So we have a negative sine h. So we have limit h approaching 0 negative sine h divided by, so we have pi over 2 minus pi over 2, so that gets cancelled out, leaving us with negative h. So the negative and negative gets cancelled. So the negative and the negative gets cancelled, leaving us with limit h approaching 0 sine h over h. So as per definition, the limiting value is going to be 1. So this is the final limiting value of a given trigonometric function when x approaches pi over 2. So here we have the function x times tangent of 1 over x, and we have to find its limiting value when x approaches an infinitely large number. So here what we're going to do, we are going to assume that 1 over x is equals to y. Now when we do this substitution, then we also have to change the limit. So we can use when x approaches infinity, then it's clear that 1 over infinity is going to be 0. So we have y approaching 0. So our now limit changes from x to y. So we have limit y going to 0. So x will become equals to 1 over y. So we have 1 over y times tangent of 1 over x, which is equals to y. Or we can simply say, so we have limit y going to 0 tangent of y over y. So as per our definition, this limiting value is going to be equals to 1.